All right, let's look at 16C, which is determining normal probabilities. So let's remember from last time. Any normal distribution, we say X is approximately normal with a mean of mu and a variance sigma squared. So sigma is the standard deviation, and that's the number that we use. If Z is a standard normal, it has a mean of 0 and a standard deviation of 1. So remember that Z equals standard normal. So sometimes they'll just tell you that a distribution Z, and you'll have to know that it's 0, 1, know the difference between those. So if we wanted to find the probability that Z is between -1 and 2.5, what does that mean? What's the probability that it's more than 1 standard deviation below and less than 2.5 above? So let's draw it, and it always helps to draw it. It just makes things make more sense. So -1, that's 1 standard deviation below. 2.5 is 2.5 standard deviations above. So it's this area in here. So what we do is we use our calculator to find that out. I'm going to show you that diagram. All right, so check this out. I'm just going to flip my screen around, and we go menu, 5, 5, and it's a normal CDF. So it's a normal cumulative distribution function. The lower bound we said was -1. The upper bound, 2.5. We know it's a standard normal, that's pre-filled. So we end up with 0.8351. All right, so say what if it was the probability that Z is greater than 1? So I'll draw a little diagram so we know what it looks like. 1's about here. What's this bit here? So we always use an upper bound of infinity because it goes up to infinity. We always use a lower bound of infinity. Even if it's something like time or distance and it can't be negative, we still always use negative infinity. So let's do Z greater than 1. Menu, 5, 5, and it's still 2, normal CDF. The lower bound is 1 and the upper bound is infinity. So control, let's find this menu. There she be. And again, pre-filled 0, 1, 0.1587. And always check that it makes sense. Like if you look here, this is saying about 84% is in this region, which is probably right. This is saying about 16% in this region, so that's probably right too. So that's how we can find our normal probabilities. Other times we'll be given the area. So say this is the area, the 0.83, or the 0.16, this is the area. And what we'll have to do is you'll have to find what that score is. So if we have something like, let's do this one. -1, +1. We already know that this was 68% or 0.68. This was 0.16, this is 0.16 because it's all got to add to 1. So what I'm going to do, and we always do the area on the left, we always do the lower, is I'm going to say, what's the probability, what if my area was 0.68 plus 0.16, that's 0.84. If the area was 0.84, what would this be? Well, we know it's 1, but we're just going to show how the calculator will know it. So look up here, and this time we want to do menu, probability, distributions, inverse normal. So you use inverse normal when you know the area and you want to find what that Z score is or whereabouts it is if it's not a standard normal. So we said our area was 0.84, pre-filled, and that tells me 0.99, which is close enough, isn't it? Because we said it was 1. The calculator tells me it's 0.99. So when we do methods, we're a bit more precise than we are in further maths. In further maths, we're happy to say that was just 1 standard deviation above. Now we're saying really it's actually 0.99. So what would we do if it was this one? 2 standard deviations. We know that this is 0.95 and these were 0.025 each. I might work out this area. So I can find, that should be about 2, my answer. So if the area is 0.025, what's that Z score? So on our calculator, menu 553, whoops, menu 553. The area was 0.025, pre-filled, happy days, minus 0.196. Sorry, 1.96. And we know we've said about 2 standard deviations, and I think in further maths you might use 1.96 sometimes, and that's where it comes from. It's just a little bit more precise. All right, so let's do a few questions. So I'm going to tell you that we have a distribution X, and it's normal. It's got a mean of 100 and a standard deviation of 6. I want you to find K if the probability that Z is less than or equal to K, well, we've already really done that one, is 0.95. All right, let's have a look. I thought we sort of done one a bit like that, but anyway, bear with me. So we want this to be 0.95, so it's most of it. We want this area to be 0.95. What does this value of K have to be so that the area to the left is 0.95? So menu 553, because we know the area, so it's an inverse normal. And menu 553, the area was 0.95. This time, sorry, it's not pre-filled. This time the mean was 100. And the standard deviation was 6. So we get K is 109.87. And then we look and we say, does that make sense? Well, we know that the mean was 100, that was here. So the fact that this is 109.87, the standard deviation 6, probably, I reckon that is probably right. What about one from the textbooks? This is 16C, and this is question 9. And it says, find C if the probability that X is greater than or equal to C is 0.8. Actually, that is not an X, it's a Z. So we know that it's a Z, it must be normal 0, 1. So even though that's not told, we know because it's a Z. So the probability that Z is greater than C is 0.8. What does it look like? Well, C is going to have to be here, because if this is 0.8, it's going to be below the mean. So if this bit's 0.8, this bit is 0.2, and we always have to do the bit on the left-hand side when we put it into our calculator. So let's go 553. The area is 0.2, and we've pre-filled on the mean and the standard deviation. Menu 553. Oops. Sorry about that. Menu 553. And the area this time is 0.2. So the Z score, our calculator tells us, is minus 0.8416. And that makes sense because if this was 0 and the standard deviation is 1, it probably is about that far underneath the 0 to make that 0.2. So it does make sense. How does it get harder? And this will be the last one that I'll do. This is just an example. If X is normal, 106 squared, so that's the same as we had up here. And the probability that X is between C1 and C2 is 0.95. We need to find C1 and C2. All right, so let's draw it. C1, C2, 0.95 here, 0.025, 0.025, because it adds to 1. So if we wanted to find, first of all, how about I just find C1? I know the probability that anything is less than C1 is 0.025. So if I put into my calculator, menu 553, let's do it. Menu 553. The area is 0.25. No, it wasn't. It was 0.025, wasn't it? Don't do that. The mean was 106. We get 88.24. So that's our value of C1. 88.24 here. Now, there's a few ways of getting C2. What I could do is I could put in the calculator that the error is 0.975 and do a menu 553. Let's do that. All right, so I'm going to do a bit of a shortcut here. I'm going to just copy that down and make this 0.975, and we get 111.76. Okay, that's an easy way to do it, but another way I could have done it is actually said this is symmetrical, so the mean is here, which is 100. So this is 11.76 above, this is 11.76 behind or less than. So it doesn't matter, whatever the way you want to do it, but the symmetry can be valuable. So there we have the values of C1 and C2. So what I'd like you to do now is go ahead and do 16C, and I think we'll wait to Thursday to do 16D because there's no real rush. So just do this today and do it properly. All right, thanks.